All right, the final question. This question, we really didn't need the reduced row echelon form of this matrix because we had 5 vectors in R4, meaning that there was no way, however we did this, we could have possibly ended up with 5 pivots for our, 5 pivots for our 5 vectors because we only had 4 rows, right? And so here we see that 1, 2, 3, 4. So this would span if this had been a question about EV2, but it's not a question about EV2. It's a question for EV4. It's asking if these vectors are linearly independent. And no, the vectors are not linearly independent. Because the number of pivots 4 does not equal the number of columns or vectors 5. And then if we want to get fancy again, we could do exactly what we did before, and we could realize, okay, if we look back, we can see where the problem child is, right? We could actually call out vector 5 in this list. That is entirely based on how this was put in, right? In the order these were put in. We could rewrite this to make the other 2, but that's fine, we'll get there. This is equal to 1 of the V4s plus 1 of V3. And then plus 2 of V2. You could just double check that, like with 1 or 2 of these to verify. It was 2 plus 1 is equal to that. So this would be -6 plus 4 is -2, check. 2 plus 1 is 3, check, right? So this is definitely what we could point out. Now, like I said, though, this means that just depending on order, these 3 vectors are linearly dependent. Looks like vector 1 is not involved in that situation at all, so it would never ever be our dependent vector, but any one of these 4 vectors could have been, depending on the order that these are put into that matrix and what we solve for. But yes, V5 is a linear combo of those last 3 vectors. Boom.